Hello, welcome to my bench. Today we got this little Micronta meter. Cute little guy. Old, I remember these. This one was the voltage doubler. This one had 2 voltage ranges on it, where you could go from, like, if you had this on 10 volts, divided by 2, and it'd be 5 volts. So that was nice. The knobs are over here someplace. Here they are. They're here. And your ohms adjust. And you had to have it in volts, ohms, and amps direction for it to work on ohms. It takes... Are those quarters? Can't tell if those are 1/4 inch or not. Or whatever, 4 millimeters. Yeah, they are. They're 4 mils. They don't look like it, but they are. And they were, not a bad little meter. Go 50,000 ohms per volt. Yeah, 50,000 ohms per volt, I guess, DC, and 10,000 ohms per volt AC on the different ranges. On the regular straight range is 50. On the doubler range is 25K. So had a little bit better burden, less burden voltage than the burden current than the other other meters did. It came with real fuses, even a spare place to put a spare, 0.75 amps, and a nice little current shunt up here. This one has a couple little problems. One of them being that somebody left the batteries in, and yuck. And the other problem is this broke. The little broke off down here, and if we look in here, that's where it broke off of. This whole piece here and this, I don't know how it even was supposed to work in there to get it through it, but it doesn't come apart that I can tell. Or if it did, it's glued together pretty firmly. Maybe, yeah. Oh, now I know. Well, that's cute. Well, that'll still work just fine for what I had in mind. Anyway, I thought about this for quite a while and could not just, my brain kind of fell apart. That's interesting. Now I know how they got it through there. Oh boy. Anyway. I sat to work and played with it for a while, and I came up with this. I 3D printed a new piece. Actually, I 3D printed 2 new pieces. I wanted to make it stronger, no matter how it went. So I also printed a little sleeve to go over it. So this piece fits inside the sleeve like that. Now I got to poke that out of there without going through the finger. And then the sleeve will go through the hole. I had just enough room to widen the hole here, and it'll go over the top of that like there, and that'll make it, I think, a lot more sure. Little touch of super glue when you're sure you got it right. And I found out that in Tinkercad you can scan in a picture of something. So I scanned in this guy. I originally started, I made this circle, those circles. I didn't see that piece in the middle. and the holes. And then I scanned in this. Well, I didn't make the holes then. And then I scanned this thing into the into my scanner and changed the output of this to an SVG file. And then I was able to import that SVG file into Tinkercad, shrink it down to the right size, and then I got this little lump up here on the top. That little lump is important because what it does is it comes over and it closes this switch. So it's a rather complicated little piece here, but it worked out really, really well. I was quite happy with it. I printed this at 75% with just PLA. We'll see how good it works. It appears to be holding the screws just fine. I got the screw holes lined up perfect the first time. So what we're going to do is we're going to put this back in here, and we're going to try this and see if this works the way I think it will. So let's get her down there on the board. We'll get this guy pushed up on here like that. About as good as it'll go. It's right down to the base there. That's nice. We got this in 0. So if it's in 0, that means that, or off, that means that this little flat edge over here goes where that switch is, because it doesn't actually close when it's off, of course. That's for continuity. Alright, got it down there. So we've got it mashed in there really good. They're making really good contact right where they're supposed to. And the switch is not closed. Let's go to continuity where that little bump is. If you look here, you can see, watch, when I turn it to continuity, it closes that. See? And then when I go past it, it opens that back up again, and that's resistance. So let us put some batteries in it. We're going to have to clean up this battery compartment. Which way? This way. I just scraped that off to make it so it would work. But let us get a set of leads here. Oh, this will do. Okay, so this is common, and this is there. Let's take it to continuity and see what happens. Yay! Can you hear that? Cool. And then when I go to ohms, I'm on R times 10K. Ohms still adjusts. Open it up. Alright, it's zeros. What about voltage? Now I do have one busted pot in here. I don't really know what it's for. I can't find a schematic for this thing, but I do know it's a 5K pot, which we'll replace. Alright, we'll put this on, I don't know. Let's put it on 8 volts, just because it's easy. I'm on the 10 volt scale. See what happens. Took. Oh. Alright, and it's even accurate. Holy smoke, that is pretty good. Well, okay, let's drop this down to 5 volts, and I'll show you what the 10 does, what that switch does. There's 5 volts exactly. So let us put that on there and switch it. Now it's right on 10. See? 10 volts. dead on. When I switch it back over to here, it'll drop down to 5 volts. Exactly, right there. So, that works. Beautiful. Now, I know that that is exactly where it's supposed to be. Well, I know where it goes when it's on the 0. By the way, if you ever take one of these things apart, be very careful because there's a little ball bearing underneath this that will scoot off across the room and you'll never find it. I got very lucky. I found it. I was surprised. Well, it involved taking this stack of super magnets here on the end of the stick and sweeping the floor until I found it. But I did find it. All right, so let's see. What is the one? Oh, there's the one that's busted. So let's see if we can get it out. I'm sure it'll come out pretty easily considering its pieces. Ow, that's hot. Probably supposed to be. I'm pretty sure I have. Well, I know I have 5K pots. Something that'll fit here. There we go. Oh, it came out in chunks. I don't know what happened to that. It just fell apart. Well, the little pinchy bit. The way these things are put together is pretty chintzy. Here, I'll show you. Here's the. Let's take the batteries out for now. Battery up. Here's the little piece that fell off. That's the little wiper. And if you look here, this goes like this. This goes like this. There's little clamp thingies that on the very edges here that hold that back piece on. And then this piece goes over the front like that. And then there's a little tab stake that goes through the back, through that hole in the top, and it spreads its little wings out. And when I get one here, let me find one. The pot collection box, 100K, 10K, 25K, 250K, yeah, no, okay. Here, what's this? These guys are not well marked. So, I mean, if I have to, I can stick a 10 turn. I got a 10 turn 5K that'll fit in there. Wow. It says 10K. So those all say 10K. Well, okay. You never have exactly what you... The 10K would probably work just fine. But I have... It'll just... I got these. Let's see if we can come up with one of these guys that'll work. These are 5000. So I'm pretty sure that this is 5K. Let's find out. I thought that's what I measured this as. Go across the 3.5K. That's not even a value. 3.3K. We're sticking a 5 in there. Anyway, so sure, why not? I think this will work just fine. $5K is not one of those real normal values. Let's bend this down like this. Take this one in here. Straighten it out a little bit. Let's I think I'm going to have, am I going to have enough room? Well, not really. Alright. We'll have to bend it back just a shade. No matter how I do this, it's going to be more rugged than those cheapies that were in there, I'll tell you. Alright, let's tack some solder on here just so I can get it to hold it. There we go. Alright, now, yeah, it's there. I do not know what that's for. It says E. I don't know. Well, I suppose we can find out. Put the battery back in and see what is not working correctly. How's that? All right. Let go. All right, so over here and over here. Common will go to common pretty much no matter what. Alright, so let's see if that is, we'll take this voltage down to about 2.5 and see, whoa, what we get. Oh, that's 0.25. Holy Hannah. Okay, so that's 2.5 volts. Turn it times there. That's on the 10 volt scale. That would be not right. That would be 4.5. So no, I got 2.5 volts. So what is it if I take this all the way up here on the 10 volt scale? Yeah, I gotta get this knob where it's in the right spot because it's confusing me. Okay. All right, so I'm divided by 2. I'm on the 10 volt scale, and that's 5. Okay, so I'd be reading the 5 volt scale, and that says 2.5 right there. Yep, dead on. Alright, so the 50 volt scale, straight. Let's take it up to 25. There's 25, dead on. Divide by 2, dead on. So 0.25. This is going to be fun. All right, let's see. That's about as touchy. It says 0.3. Wow. I can't even measure the other one. So it's not the voltage. Let's get the resistors and see what we can find out here. Well, let's get one of these guys. They're big enough to handle. And a little tweaker tool. And let's put this as a what? This is a 500. There's a 50K. So we'll put it on 10K times 10K. Set that. Put this in the center. That's cool. Go to the meter here. Over to ohms. And hook this up to here and here. $636 ohms. Alright, and this is me reading R times 10, R times 100. Oh, wait a minute. Is it reading voltage? Yeah, okay, so it's reading voltage from there. I can't do that. So, that would be interesting how you would do. Okay, so let's take okay, so it's cranking down. And it should stop at 5. It does, sort of. Does this meter adjust that? Does this pot adjust? No, it does not. Alright. So, let's take it back out to approximately 1K. Turn this way. Well, that'd be 10K. Let's get this on by this meter reckoning on 10K. Alright. And then read it with meter on the screen. And it's a 12.5. So that is off a little bit. Do you adjust? No, it's definitely not that. Okay. Is it volts AC? How can I get volts AC? Let's see. turn on the audio generator. I've got it set for 2.7 volts RMS. Okay, let's take this up a little bit because that's... There's 10 volts RMS. You adjust that. No. So it's 10 volts RMS, I believe. What scale am I on? So that's 10 volts peak, all right, coming out of there. So that would be 10 divided by 2 equals times 0.707 equals 3.535 on AC on the 10 scale. It's 3.4, right at 3.4 volts. So that's there too. Current. Well, how can I do a current thing? I want to draw a certain amount of current. Well, let's see. How would this work? Let's see. So I would take, coming out of the power supply, volts, ohms, amps. Let's put it on 500 mils. Coming through there. Okay. To here, to the little, to this little guy. And then this goes to here. Okay. Give it some voltage. There's 3 volts. How am I doing here? No. Alright, so coming out of the power supply into the plus lead. Getting confused here. There. Just had it backwards. Okay. Alrighty, here we go. Into the plus. Let's draw a little current. Oh, I got my current set way down so it don't blow anything up. So what do we got? Oh, okay. There's 500. 500 mils, 500 mils. Let's see if this is just this. Yep. There we go. Come on, baby. There's 500 mils on that. Let's take it down to 50. I don't know how accurate that is. I only have 1 digit of resolution on this little thingy, but we're going to presume. Okay. Uh, 500 and we're going to go with some. I'm going to adjust it here for this because I believe this would be much more accurate. Come on. Boy, it's hard to do. Well, this 10-turn pot makes it nice. And we got it. There we go. Right there. 4.9 amp 5. 100th of an amp. Cool. Alright, well, that takes care of my current. Let's try the 10 amp scale. Take it up, I don't know, 10 volts. And I can only draw like 3 amps, 10 volt scale. Wow, it's right on. Almost perfect. So, yes, that works. I'm not even going to try 1,000 volts because I don't think this meter would handle it to begin with. Well, it looks like we did it. Alright, so everything appears to work and it appears to be accurate. I'll go through it with a fine-tooth comb here. And I got to put some glue on that guy. Oh, it feels good. I mean, it turns nicely. That turns really good. I got to put some glue on there, pre-drill a hole with a little washer and a screw on the back there, so that'll hold that in even better. And I think we got it. I really do. So, let's see. Well, while I'm thinking, I'm going to put these screws back in. It's got to be these because there's only 4 of them. The camera's back a lot farther than normal today. I hope the top will still go on. Oh, it should. Yes, it does. Good. Yay. I was worried considering that, that thing is sitting there. Alright, okay, well, I guess it's super glue it is. This should be interesting because I got to do this rather quickly and I got to get it right the first time. Make sure it is off. It is off. Just a little bit's all I want. I'm not going to make a big glob out of this. Push it down good. It's on its thing. That's pretty close to the center. Yeah, that glue took like right now. I don't want to try too hard. Alright, well, tell you what. Oh, we gotta clean this, don't we? Okay, let's put this back. I gotta get better about putting things back. So, we gotta clean that off. What have I got? I got a little steely brush here. I'm going to get off as much as I can with this. Wow. That's fugly. Wow. Yeah. Ugh. Well, it didn't tear up the plastic. I mean, it didn't eat up the plastic all the way through. There's a little tiny bit over here on the 9-volt side, but that just wiped right off. Okay. Baking soda. Alright, baking soda. Well, that's going to have to soak. So, you guys don't want to watch that. Anyway, clean this thing up. Make sure that it works. Put it through its paces a little bit. And I think we got a fix. Got a new one of those. I think it's stronger than the original. And sure works well. 3D printed. I love that 3D printer. That is such a cool idea. Hey guys, thanks for stopping by. And give it a thumbs up if you like it. Don't forget to subscribe and ring the bell so you know when I'm doing more of this stuff. Till next time.